Hi, everyone. Thank you for coming and welcome. My name is Tiffany Long. I am excited to have you all here to explore all of Traefik Proxy's 2.6 features with us. My colleague, Jakub Hayek, will be walking us through these features, telling us about them, and then giving us an awesome technical demo about how you can use them immediately. Before we get to that, I'd just like to note that if you have any questions at all, please drop them in the chat. I'll be collecting them throughout his talk, and he'll be answering them at the end. Now, there's a lot of really cool stuff happening today, so he might not be able to get to all of your questions. That's okay. Drop as many questions as you have. What's going to happen is when this is over, Jakub's going to answer all of the questions for us, and then we're going to send it to you in a gist in 24 to 48 hours after this event. So don't worry, you're going to get a copy of the presentation. You're going to get all of the questions answered in a gist. And of course, because we're open source, all of that will also be available on our GitHub. We're really excited to get started, but I guess first I should introduce myself. I'm Tiffany. I'm the new open source software community manager. I'm a longtime builder of communities. And most recently, I come from a security background where I was working with hackers of the world through bug bounty programs. And before that, I was working with security professionals through organizations such as OWASP to help create open source security options. Not all of it was software. And on a personal note, I'm a huge travel enthusiast. So if you see that I'm coming to a place near you, please reach out. I'd love to talk to you about how we can make our community better and more awesome. With that said, let me introduce Jakub. Jakub Hayek is our colleague at Traefik Labs.
Yeah, hello everyone. My name is Jakub Hayek. I'm so delighted to give you a presentation, today's presentation about the Traefik 2.6, what has been released in that version. Let me just briefly introduce myself. I work for Traefik Labs. My role is called Product Adoption Specialist, and my main responsibility is actually to support enterprise customers and provide community support. I'm a huge fan of Kubernetes and everything what is related to that great technology. I practice a lot of stuff around the commonly known word DevOps, so I like all those tools which makes our daily duties as operator much easier. And when I'm not working, I'm a proud dad of my son. Yeah, so let's move forward. What we are going to talk today. So there are a couple of things that I would love to present. So the content will be following that. We will present just a little bit of slides. So I will discuss what are the new features, and then I will give you a technical demo. And everything is prepared for the demo because setting up the environment during the webinar would be so time consuming. So I decided at that time to prepare everything and just show you the entire configuration on the live environment. So the first topic we are going to discuss is Traefik Gateway API provider, and in 2.6 version we added Gateway API. We added support to Kubernetes Gateway API 0.4.0. So there are a lot of changes we are go through what is new. The next feature that we added is advertised port for HTTP3. So now you can easily configure the UDP port that should be used for advertised. Next cool feature is a inflight connection TCP middleware. That is one of the another middlewares that are added in Traefik, but this time it's a TCP. And a Consul Enterprise support, because you might ask yourself what Consul is, why Consul? Yeah, the answer is pretty simple. Traefik Labs and HashiCorp will settle a partnership, so we decided that we'll add the support for their enterprise platform. So there are lots of to show in regards that topic. So yeah, and then the last one would be demo. So all of the content that I prepared for that workshops, for that webinar, will be available just after the webinar at that link. Currently it's my private repo. I will just make it public after the webinar. Yeah, so let's start with the first feature, that is a traffic gateway provider. And there is a lot of new APIs that has been added. We currently provide, as I mentioned, 0.4.0. It's V1 Alpha 2. That's the version of the API. You can see the link and learn more about what are the other features available for that provider. But let me just briefly review CRDs that you can use. So first of all, it's a gateway class. So in order to use traffic gateway provider, you need to create gateway class, and it's just a set of the APIs to expose Kubernetes services. It might be a layer 4 on layer 7. Then you need to create gateway. So it's another CRD from Kubernetes Gateway API. So it's kind of a logical load balancer implementation. So in that case, it will be just traffic. And we have a HTTP routing and HTTP traffic splitting. So both of them are able to expose, actually to create network traffic from the gateway to your backend. So it's a kind of a ingress that we can compare to the previous older version, commonly known as Kubernetes Ingress or Kubernetes CRD. And traffic splitting, it works as a weight and round robin. So it allows you to create two services and configure weights between them. And based on some other extra features, you might introduce to your application deployment strategy, something like progressive deployment. It might be called canary, blue-green deployment, whatever you like it. And TLS, it just defines you a way how to terminate or just set pass-through TLS on the gateway level. TCP routing is quite similar to the HTTP, but it's for TCP services. And yeah, one of the features of Gateway API is cross namespace routing, so you can share the load balancer across your other team members. So in order to enable traffic gateway API provider, you need to just add those two lines to the static configuration. As you already know, traffic has two types of the configuration: static and dynamic. And this is a static, so you need to add that as a CLI comments as it's presented here. You can use a file. It's actually it depends on you what way you prefer to do that. Then we can create a gateway class. So it's one of the API that you need to create, and what is important here is a controller name. So it just indicates that you will be using traffic as your ingress provider. And from the diagram perspective, for me the diagram is helps me to understand what is happening inside. So we have in our Kubernetes cluster, once we create a gateway class, then we can create an instance of a load balancer, and it will be a traffic proxy as a gateway. It's a CRD from Gateway API, and then we can create HTTP routes. So in that case, it will be full route or bar route. And in host, you can define what is the host, what is the prefix, path prefix, and based on that specific rules, it will be the request, the network traffic will be redirected to the Kubernetes service and then to pod on your cluster. Similar here, but the difference is that we use, for example, a header, specific matcher in the HTTP route object. We can have a canary deployment or any kind of progressive deployment. And now I'll try to show you how it works on the live demo. Yeah, so another new feature that we have introduced is HTTP3 configurable advertised port. So as you already know, Traefik is supporting HTTP3 from 2.5. That was the first implementation of HTTP3. The major difference between HTTP2 and HTTP3 is actually the protocol, because the HTTP2 relies on the TCP protocol, and now for HTTP3 that is still in the draft mode, we use UDP. And you need to open Kubernetes. If you are creating a load balancer type in your Kubernetes cluster, you need to expose two protocols, so TCP and UDP. And it's quite tricky, especially if you work with Kubernetes, because load balancer type service that is used to expose traffic to internet accepts the only one protocol. So if you would like to use load balancer type, you need to switch to node port, and I will explain in a second how to manage that. In order to turn on HTTP support, you need to add to the static configuration those 3 lines. And once it's enabled, Traefik will be able to send back in the response following header. So that if the browser initiate connection to the server, to the Traefik, it will start the HTTP session using a HTTP2 protocol and TCP. But if the Traefik sent back in the response following header, your browser can decide, okay, I would like to switch to HTTP3, and I would like to, and it will open the new subsequent connections using that advertised port, and it will go through UDP. And in most cases, that port is equal like HTTPS, but it might be now you can configure it as totally different port. So it's quite flexible way to work with HTTP protocol. Yeah, as I already mentioned about the load balancer type service, and I encourage you to, if you play with Kubernetes with cloud provider, you have to use node port instead of a load balancer type service. That's the definition that I use in my demo. So I expose TCP and port 80 and port 443, and the same port for UDP. And then using I manually created NLB load balancer on AWS, created target group and match and map those things together. Because this is what AWS is allowing me to do. If you don't have such support in your cloud provider, you can use a different port for HTTP3. If you are using your Kubernetes cluster on-premise, there are also some alternatives, so available solution that works actually pretty well. One of them is a Metal LB, and it has an IP address sharing feature. So you can have one IP address that use 2 protocols, TCP and UDP, and you can achieve very similar solution as I just described. For lightweight version of Kubernetes, for example, for K3s, there is already a Clipper service load balancer that is able to do similar thing. So another feature that we added to 2.6 in-flight connection middleware. But before going further and explaining what is it, what this middleware is doing, let me just briefly introduce what are the middlewares in Traefik context. So Traefik has a feature called middleware, and we have dozens of middlewares for HTTP. And what is it? So it can tweak your request, it will modify the response, and it's applied on the router level as it's described on the diagram. So we can apply a couple of middlewares here and do something with our request. For example, it might be commonly known basic authentication. So you can add middleware basic authentication, and you can have your users will be asked to enter credentials in order to access the service. It does not modify any runtime data, but this is how it is. So for HTTP, there are lots of middlewares, starting from those like basic authentication, strip path prefix, circuit breaker, rate limiters, and many other. For example, OpenID Connect for authentication. So it's quite powerful. But recently, starting from 2.5, we started to develop TCP middlewares, and this time we are adding a new one, which is called in-flight connection TCP middleware. So what this middleware is responsible for, it actually allows you to prevent your TCP service being overwhelmed with a high load. So you can define how many simultaneous connections might be established with the service, and if the amount is higher than if the number of the connections is higher than amount, yeah, next connection will be just dropped. Again, it's quite tricky in Kubernetes, considering the Kubernetes networking, source IPs and all the stuff that are related to Kubernetes networking, but still it works quite well. Yeah, and another feature that I would like to discuss is, again, Consul Enterprise support. So as I mentioned, we settled the partnership with HashiCorp. So we added a lot of features to integrate with their platform. So the first is a Traefik Consul catalog provider. So it will, if you use that provider, you can easily you can have a feature to automatically discover services that are running on your Kubernetes, and that service, thanks to the annotation added to the Kubernetes service, will be automatically created in Consul catalog. So I see that you can use, for example, if you already have some of your applications using Consul catalog, then you can use Traefik to expose them to the internet. So it's a nice feature if you already have some infrastructure that is using Consul catalog. Yeah, another is you can use Consul as a key value data store. So we have a Consul key value provider, so you can manually add configuration using the key value. And Consul Enterprise has a feature, has a namespace feature. So you can create a namespaces and you can add some of your objects to the specific namespace. And in my demo, I will be using the namespace, dedicated namespace for services, and it will be using for Consul catalog, and I will be using the dedicated namespace for key value data store, and it will be just for the Traefik configuration. So we'll create middleware in Consul key value data store. If you'd like to learn more about the integrating Kubernetes and Consul services, there is a very nice tutorial on that link. So there are again static configuration, and if you'd like to add support for HashiCorp Cloud Platform and Consul catalog and Consul, following CLI commands has to be added to the static configuration. And as you can see, as an endpoint, we are using a private URL here. And I will explain in a second how it's designed, how it's created. We have to also use a token here and default rule, because once the new service appears in Consul catalog, Traefik will create dynamically router based on that rule. So here will be the name of your service, and it will be dynamically created. For key value data store, it's a little simpler. We just use a token, and again, we need to have endpoint added and the namespace. So that's the diagram how that entire configuration works. And HashiCorp Cloud Platform use under the hood AWS, so it uses VPCs. There is a VPC where once you deploy Consul, it will be running on a specific VPC. And if you deploy your Kubernetes cluster on AWS, it might be EKS or it might be any other kind of a Kubernetes that you provision it manually using a kops, kubeadm, or anything else. You can still use VPC, and you can create peering connection between those two components. So you don't have to, in order to reach Consul, you don't have to go direct through the internet, but you can use a private, let's say, tunnel, because this is a secure connection between VPC A and VPC B. So here is my Kubernetes with Traefik, and that's the Consul running outside my infrastructure, but it's still using the secure connectivity. And once I deploy Consul agent on my Kubernetes, it will connect to the Consul server here. So it will be, that Consul will be responsible for service discovery for Consul catalog, and the data that will be discovered here will be pushed through the tunnel to the Consul. So that's a nice feature, and I will show you how it works. So that's the example of the Kubernetes service and what you should notice here, there are some annotations added. So those annotations are for Consul agent that is deployed on the Kubernetes cluster. And once I add that annotation, it means that it will be created service called Who Am I? That annotation means that everything from Kubernetes that contains those annotations will be created in Consul catalog. And here you can find some specific only for Traefik tags. So we enable Traefik, we create entry point web secure, we are adding the default TLS, so it will present the default certificate, that is TLS certificate that is added to Traefik. And it also use middleware. So the middleware will be strip prefix. But as you can see, the provider for that middleware is Consul. So as I mentioned, services will be keeping in the Consul catalog in the dedicated namespace. But for configuration, middlewares and any other stuff related strictly to Traefik will be keeping in the key value data store Consul. So this is how it has been configured. Yeah, so it's all about the presentation and slides. Let me now switch to my console and let me show some demo. So the first thing I'm going to show you is configuration with is Consul Enterprise demo. So as you already, yeah, so that's my cluster. I'm connected to my cluster and I'm in the namespace Traefik. And there is a Traefik deployed. Let me check. Hopefully Traefik is working. Yeah, has been deployed 5 hours ago. Let's describe what is the Traefik configuration, what are the CLI comments added. So let's go here. As you can see, we use Consul endpoint for key value and Consul catalog for Consul catalog provider. Let's check whether port forwarding is up and running, and let's see what's happening in the dashboard. Dashboard should be up and running. Yeah, as you can see, we have a Consul catalog and Consul provider are already available. And now we can go to the Consul UI. So that's the Consul that is running in HashiCorp on HashiCorp cloud platform. And I create a routing here because that's my private, that's our own domain, but in the routing it goes to that private endpoint that we created in HashiCorp cloud platform. So this is actually that endpoint that we are referring to, and now we are just exploring what's happening here. And we use the token to authenticate that Traefik is able to talk to Consul server. Yeah, as you can see, there are nodes already created. So that's the leader, and those 3 are agents deployed in the dedicated namespace, Kubernetes, Consul, Kubernetes, Consul agent. And as you can see, I deployed Consul agents here. And those Consul agents are connected to HashiCorp cloud platform. Yeah, just one note. Everything what I'm just presenting is described here. So you can repeat all those scenarios by yourself using my tutorial that I will just share after the webinar. So let's check what's happening inside. So I deployed sample application Who Am I? And as you can see, I'm using that annotation that I just presented. The application is pretty simple. Service has been created, and service should be also created in Consul catalog. So let's check whether that app is deployed. Yeah, there are 2 replicas of that application deployed. Let's check whether service is deployed. Describe SVC Who Am I? Yeah, this is exactly that service that I'm just presenting. We can see that those annotations are added and the Traefik tags are also added here. So we should go to the namespace apps because our services are added to to the namespace apps, and as you can see, there is a service who am I with those two replica, and as you can see, there are all those annotations, those tags actually that are not, it's already tag, so that's those tags are added here. So if we will go to traffic, to the routers, we should see that application that and again, let me make it bigger. That's the first step. Yeah, and as you can see, because the name of the service is who am I, the default rule created router called who am I f1 demo traffic labs.tech, and the provider is Consul catalog. Let's go there, and as you can see, we also added middleware that is created in Consul. So that's another feature that we have added because we are able to use traffic namespace, and we have a middleware is added here, and the first item 0 and the value is full. So the path to that key is traffic HTTP middlewares, the name of the middleware, the name of the object, the name of the middleware, prefixes, and the first item is and its value. So now we can use that middleware here, and now we should be able to go to HTTPS who am I -k, and we should get the response. Yeah, so it works. Traffic was able to reach the backend, the who am I application, and now let's try to check if the middleware is working correctly. If so, we should see the new HTTP header that should be added in the response. And yeah, as you can see, it works. So we have a new header. It means that middleware works fine. So that's the quick demo, but I think it gives you the overview of what is the Consul catalog, what is the Consul, how to integrate traffic with HashiCorp Cloud Platform, how to use a VPC peering connection, and how to use private URLs, private endpoints to reach the Consul. Okay, so the next, what I would like to show you, actually, it's, let me close it, it's Gateway API. It's Gateway API. So the first step, what you have to do in order to play with Gateway API is to add the CRDs, because a Gateway API requires you to add specific CRDs, and you can do that by just executing. Let me scroll here. Just using the kubectl customize, you can go to the GitHub Gateway API directory, and you can apply on server. I also added those CRDs here. Let me check how it works. Let me check those CRDs actually. Get CRDs. Yeah, so CRDs are created, and the next step is to deploy traffic with specific configuration. So we need to have Kubernetes Gateway equals true and experimental Kubernetes Gateway equals true. So this is how it should be configured. Let's check whether it's created. Let's go to the Kubernetes traffic, describe deployment traffic. And yeah, as you can see, those two CLI comments attributes are added here. Experimental gateway true and provider gateway, Kubernetes gateway true. So now, if it's up and running, we have to create gateway class. As I mentioned, I already created the gateway class, so I will just only check gateway classes -a. Yeah, object yeah, has been created 6 hours ago. Gateway classes, traffic gateway. Let's check what's the controller name. And yeah, spec controller name, yeah, that's the traffic IO gateway controller. So we know that we will be using traffic as a gateway controller. So now we should create a load balancer, but let me go to the, it's in default namespace. Yeah, I deployed 2 sample application, WhoAmI v1 and WhoAmI v2, and differences between those 2 apps is actually what we will get in the response. So the first application will return ASCII logo foo, and the second application will return ASCII logo bar, because we'll try to do traffic splitting, and I would like to show you how it works. So those 2 apps are deployed, and now we can check whether gateway is created. Gateway. Yeah, gateway has been created correctly. It used traffic gateway class. It's ready. Let's describe and check what are the listeners added. Gateways, traffic gateway. Yeah, we have 2 listeners for HTTP and for HTTPS. Both of them are ready, no errors. Let's check what is its definition. Yeah, so that's the definition. We use a gateway. It's created in the namespace default. We use a gateway class name, traffic gateway class, and we use 2 listeners. And we also use TLS termination on that port. And we use a self-signed certificate, because you can use certificates for domains, but in our case, we just created a simple self-signed certificate, and it's a Kubernetes secret. So now we should create first router, because we would like to see those 2 applications, how we can reach them. And the first router is actually pretty simple. So it's an object kind HTTP root, the name is WhoAmI app, traffic gateway, host name, and the matcher. So it will go directly to the root level, and we use following backend. So WhoAmI v1 on the port 80. So let's apply it. So it's 02 gateway API. It's here. Yeah, so it has been created. Let's check that. Yeah, router has been created, and the application we should see. Yeah, it has been just discovered in the dashboard. Let's go there. Yeah, it has been created. Provider is Kubernetes Gateway. Let's check whether that application is responding correctly. It should. Yeah, it returns full, as I mentioned, because we goes to the WhoAmI v1. And now let's create another router that will be called WhoAmI splitting, and it will be using following host name. And as you can see, we will have the difference here is that we use 2 different services. The first one is v1, as it was in the past, and the second is v2, and we use the weights 5 to 1. So it means that most of the incoming requests will go to that application, to that service, and just only a fewer should goes here. So depending on those weights. So let's apply it. 05 get HTTP routes. Yeah, the new router has been created 6 seconds ago. Let's try to call it canary -k, because we use self-signed certificate. Of course, that's the wrong URL. Yeah, the bar, because we are going to the v2 bar, and now we are on the version 1. So as you can see, traffic splitting using weights works as expected, we can play with those weights and redirect more incoming traffic to the specific version, or we can use 50-50, whatever we like it. So what's the benefit of it? For example, we can create following canary header. I call the router canary header, and I use another matcher here. So once I add new header to my request, so the name of that custom header is X canary header, with that value, I should be always redirected to V2. So in that case, I can ask my QA team to validate the new version of the app in production environment, right? So it's the first step to have a progressive delivery on your cluster. So let's apply it. Can I get HTTP routes? Yeah, it has been added 7 seconds ago. And if I will not add any matcher, any extra header here, I will be always reaching V1. But if I will add that specific header, I should go always to V2. So let's try it. HTTPS canary header -k, and I should receive full, because I goes to the request is routed to the V1. Yeah, and now if I will add the header, custom header, X canary header traffic, I should be redirected to the V2. So the response header should be different. Yeah, and as you can see, yes, it works perfectly. I was redirected to bar. Let's see what is happening in the dashboard, because it's nice to see if we are, there are lots of routers created. Let's check that one that we are canary header. Yeah, that's the one that we have created. And let's check services, because we can see that, where is it exactly? That's the weighted, that's weighted 2. V2, V2, V2. So as you can see, those services has been created, and all of them are used automatically, and all of them are used by Traefik. Okay, so this is how the Gateway API works, and it's all features in regard to that topic. Let me go and show you something related to the HTTP 3. So I will switch to the new cluster, because it's, as I mentioned, we need to create some extra configuration in regards the network load balancer on AWS, and we need to create node port, because we can't use load balancer type for HTTP 3. And it will be a very simple demo. Let's check what has been deployed in the default namespace. Yeah, so that's Traefik deployed 25 hours ago. Let's check what is its configuration. So we use experimental feature HTTP 3. We expose following ports, entry points for port 80-433, and we enable HTTP 3 on the port web secure. And we also use advertised port on this same port as it is for web secure. So we should see that specific header, alt SVC, saying that we use HTTP 3. And again, we use simple application called Who Am I? And let me try to check it. So that's the name of my curl https -k-ev, And as you can see, it's the application is up and running because we received 200 and we received that specific header here. So it means that we use HTTP3 already, so that traffic is ready to accept. It doesn't mean right now that we use HTTP3 because curl comment initiated HTTP2, but in the response we received following header, and now another connection, if the browser is ready to use HTTP3, might go through the HTTP3 using actually subsequent connection on the port UDP. So in Firefox, for example, we should see that in following way. So as you can see, the first request has been using protocol HTTP2, but the second one is using HTTP3. It throws 404 because we don't have such an icon available here. However, it uses HTTP3. So Firefox automatically switched to use HTTP3 protocol. So that's the everything what I wanted to present in regards to the HTTP3. It's nice that we can use it. Maybe I'll just show you the node port service because that's the quite tricky part for Kubernetes. Yeah, as you can see, there are, let me make it more readable. Okay, let's describe SVC traffic and we'll see here. Yeah, so that's instead of using a load balancer type, which is the common use of traffic, and in all of my installation I always use load balancer type service, but in that specific case we have to use node port. Let me repeat why. Because of the limitation of the load balancer type service. You can't have two protocols available on the load balancer type service, but you can have it on node port, but it's more tricky. So we use TCP, and here we use UDP, and then on the AWS I created specific configuration how to manage that. But everything is explained in that tutorial here, so you will see how it's easy to set up on AWS. Yeah, so this is the everything in regards the HTTP3. Let me show inflight connection middleware, and this is what I had to change here. I had to add new entry point because this is TCP connection. Traefik is able you to use TCP connection on web secure middleware, but you need to ensure that TCP has always precedence. So you need to design your routers keeping in mind that information is a precedence always will have TCP routers. So you need to keep in mind that. But in my case, I just opened a new entry point. I deployed simple application Who Am I, but it's again TCP service. It's not a HTTP. I use the load balancer type service to expose that entry point. I created ingress route, following ingress route and ingress route TCP because we are using a TCP connection here in the namespace APP, and the entry point full TCP because this is how I call it. The matcher is host SNI, and I assigned test inflight connection middleware, and that's its configuration. So those things are already created. And now let me check what is the IP address to reach that traffic instance. So it's A5. So I can use netcat to initiate connection. Yeah, and now if I type who, I am receiving the response from the pod. And now I will, yeah, as you can see, the only one connection is allowed because we allow only for one connection. So another connections are automatically dropped. But again, it's quite tricky because how Kubernetes networking is working, especially source IP, because we don't know what's happening between what's happening on the load balancers in AWS. So we need to be very clever once we created that middleware. So yeah, this everything what I prepared in regards to technical demo. All of those things will be shared with you just after the webinar, so you can repeat all those steps. You can repeat the entire environment on your Kubernetes cluster. So now I will just switch the will pass voice to Tiffany, who share with you some information about what's new in the upcoming releases, and I will try to focus on the questions. Thank you.
There we go. Hi, thanks, Jakub. So your questions are going to continue to be gathered. Any questions that we don't get to live will be in the gist. So if you don't have, if you weren't able to ask your question in time to get it answered by Jakub live, don't worry, you'll get a written answer. So I'm really excited to share with you guys what's coming up for the rest of version 2. As you can see, we have 3 minor releases coming out. And rather than just read off the features that we're hoping to complete for them, I thought I'd tell you a little bit about how we came to choose these features. So first, we really focused on community asks, but as an open source product and community, we have a lot of community asks. So we needed to find a way to create themes around what we wanted so that we could make sure that what we made was cohesive. So one of the themes that we started to focus on was continued improvement beyond layer 7. And then we realized that we've done a lot of support for Docker, but we have a little bit to go for Kubernetes. So we've decided that 2.8 is going to be all about making Kubernetes better and easier so that we can bring parity to the two. And finally, we really wanted to focus on user experience, especially in configuration. We've heard you. We really want to focus on making that better. Now, of course, all of the changes for the rest of version 2 aren't going to be breaking changes, but we're really hoping to move forward with version 3 with a focus on user experience as well as on performance. So please keep an eye out for what's coming in the future. I would like to say that, as y'all know, we are an open source community and an open source software. So if you would like to engage with us by sharing a bug report or sharing a fix, or perhaps you want to talk to us about features that you particularly need, please feel free to open an issue. And if you're like, man, Tiffany, I really want to engage with you with code, and I want to collaborate with y'all on a commit, please also reach out in our GitHub. You can see that all of our current plans, and remember, things can change, but all of our current plans are linked to the GitHub issue that discusses them or that inspired them. You will receive this slide deck. The links will all be active in there. But if you want to get a jump start on it, feel free to hang out in our GitHub. We are also going to be bringing forward some new user experiences in GitHub, including helping people find ways to collaborate with us as they wish to engage with us. So I'm going to hand everything back to Jakub, who's going to answer your questions. And remember, if a question didn't get answered right away, we will send it out to you in the gist.
Yes, thank you, Tiffany. So there are a lot of questions. I have a few of them already listed here. So the first question is 2.6 backward compatible? In the other words, can I use a 2.5 configuration and use that with 2.6 without changing anything? Yeah, yes and no. Yeah, it's of course it's backward compatible. However, you need to update middleware TCP CRD, because as you know, if you would like to use new middleware, you need to update your CRD. Other configuration things are backward compatible and you don't have to change anything. But again, the good practice is to first deploy on the test environment, making sure that everything works fine, and then just upgrade to the 2.6. So make sure you updated the middleware TCP, otherwise you won't be able to create in-flight connection middleware. Yeah, how would we do path prefix strip with gateway API with Traefik? So for now, as it is experimental, you cannot easily assign the middlewares. It will be added in the upcoming releases. So for now, it's just an experimental that presents that Traefik is keeping the pace of the Kubernetes ecosystem and updates the API, gateway API, but our features will be available soon. Does Traefik have support of transient gateway as well as peering? So VPC peering has been used because this is available on HashiCorp Cloud Platform. For now, based on my best knowledge, there is no way to use any different AWS networking capabilities to create peering connection. You can only create peering connection. So I think it's not available, but you should ask that question to HashiCorp support. How about HTTP3 and the service definition side? Can Traefik connect to other services with use HTTP3? Traefik currently is using HTTP2 between Traefik and the backend. You can't use for now HTTP3, so it's only between browser and the server, so it's not inside on the server side. Is secret management within deployment with Vault only possible via Kubernetes, or is Docker Swarm fully supported? Honestly speaking, I'm not so experienced user of Docker Swarm. I used it years ago, but it's a very good question, and I will check it and we will back to you how to use Docker Swarm and Traefik and Vault. We support Vault in general, but I haven't played with Docker Swarm and Vault, so we need to back to you with more details. Another questions. Traefik does offer service mesh, but states Traefik mesh does not use sidecar container, but handle routing through the proxy endpoints running on each node. The mesh controller run is a dedicated pod and handles all the person. Yeah, so Traefik mesh is a service mesh. It's invasive configuration, so it doesn't create sidecars. And we use daemon set, so on each of the node there is created a dedicated pod that handles the connection. So it's absolutely different way of using a service mesh comparing to other service mesh solutions. So yeah, this is how it works. In general, we don't use sidecars, we use just a daemon set and dedicated pod. Could I download recording after the session? Absolutely. Just for confirmation, is that HTTP3 switch header sending by TCP port, right? Yeah. The first call is go to the TCP, and the subsequent calls, if the browser decide to use UDP, it goes to the UDP. That's why we need to have two protocols enabled on one port. Is there anything that Gateway API provides that can be accomplished using Traefik on CRD? Yeah, definitely. Gateway API, it's, yeah, so we need to first ask the question why there is another ingress management, right? And Gateway API has lots of interesting features, reference back policies. So you can define the resources about how to use between different namespaces. And I presented only those things that currently Traefik is supporting, but there is a lot of a magic that is actually behind the Gateway API. So for now, I would like to encourage you to have a look on the Gateway API website to see why there is another evolution of the ingress management. And soon most of those features will be available in Traefik. Yeah, I think that's everything. Do you plan to provide some support for click bounty folks or keep? Should I stay on Docker Swarm or should I migrate to Kubernetes? And vital whether rely on Docker Swarm or yeah, that's the difficult question to answer. We considering our customers, there are a lot of them still on Docker Swarm, but the entire ecosystem is heading to cloud native ecosystem is heading to use Kubernetes. And we are also supporting so widely Kubernetes, and as we already mentioned, we will have more features for Kubernetes, but we still keep support for the backward compatibility support. So that's the question to actually to you, if you would like to stay on Docker Swarm or just migrate to Kubernetes. Okay.
Yeah, that sounds great. So just a reminder, everybody, we will, oh, we have one more question and I think we have just enough time. I'm going to share it with you.
Yep.
Oh,
Absolutely.
actually,
Absolutely. Let me go back to the first slide and that repo. This is the address of the repository, and I will make my repo public in a couple of seconds.
yeah. So as within the next 2 days, you'll receive an email that will include a copy of the slide deck or the recording, as well as the gist that will answer the questions. And that should, and as well as there will be this link as well, in case you don't want to type it down right now. So I think with that, we're going to say thank you guys so much for coming. We'd love to hear from you. Please feel free to reach out to us on social. We're on Twitter. We're also on LinkedIn. Please feel free to reach out to Jakub or myself as needed. We've both shared our contact information. And join us on GitHub if you have any issues that you'd like to raise. We'll talk to you guys later.
Thank you so much. Bye-bye.
Bye.